So welcome to the webinar, everyone. This is Dean Carvin with Checkpoint Technologies, and what we'll be talking about today, I'm going to kind of start slowly here just to make sure everybody joins who wants to join. But we're going to be talking about test automation implementation strategy. This is a portion, what we're going to go over in the webinar today is just a portion of a class that I'll be holding in the SQTM conference coming up later this year. We'll look at that in just a minute. So this is just kind of a taste of what we'll be talking about in the class regarding test automation strategy, techniques, design, things like that. All right. And before we start moving through some slides, just quickly a little bit just about myself so you know who's on the webinar with you. Again, my name is Dean Carvin. I've been in test automation for about 15 years now, focused mostly on GUI testing, API testing for many, many different applications, many different clients. A passion of mine is developing well-designed frameworks, and that's what this particular webinar is going to focus on, is framework design and implementation. It's part of that, and that will be part of the class, okay? So that's who I am a little bit. I'm the, I work for Checkpoint Technologies. I'm the Solutions Architect Manager. So let's begin the presentation. So first of all, let me get my focus on here so I can move slides. There we go. So first of all, we have the conference coming up beginning May 31st through June 5th. The class I'll be teaching is on June 2nd. It's that Tuesday. It's a full-day course, and there's also a test at the end of that course. All right, so if you haven't signed up for the conference yet, please do so. There's up until March 31st, you can save up to $500 for for your registration. So it's important to hit that date if you're going to be there. All right. And just as a note, this is for only those who have registered for the webinar. If you're in a theater with 300 people, it's probably not what you're supposed to do. Okay, so this is just for the individuals, all right? So some of the objectives we want to look at for this webinar. Oh, let me mention one other thing, I'm sorry. But on the side, on the GoToMeeting menu, there's an area where you can ask some questions. Feel free to pose your questions during the webinar. But I won't look at those till after the webinar. I want to make sure we get through everything first, and then I'll go back and look at some questions and answer as many as I can. Those that we don't have time to answer in the next hour, we do have a hard stop at 1 o'clock. I'll be sure to put it in a document and make sure everybody gets those answers. Okay, so just another note there. So 3 objectives we want to kind of look at for this hour. So we want to look at the fundamental elements of a successful automation framework. So automation has been around for a number of years. The term framework has been around for a number of years, but what are the common elements that make for a successful framework? If you look from one company to another, one project to another, frameworks vary greatly in their complexity. We're going to look at the pros and cons of complex frameworks as opposed to simple frameworks, okay? And there's reasons for both. We'll look at a couple case studies as well, all right? And then also learn practical steps or tips to design and implement a framework. It requires some technique, some skills that are going to be required, and we'll take a look at those too and look at the organizational level, things like that. So those are the 3 objectives we want to take from this hour, all right? So first of all, some definitions. So an automation framework definition. So a framework is a test automation methodology. It's a way to design your test automation. It typically separates out the code from the data. By doing that, it allows for separate development of the code and maintenance of the 2 assets. So you have data sitting out somewhere separate from the automation script itself, okay? If you're tying data to your script, then you're limiting the value of that script, and we'll look at how to modularize components and things like that. So that's really a high-level definition. If you look online, there's a lot of very complicated definitions, but this is something that just, as far as a framework, when I look at a framework, I expect to see two pieces to it, a front end and a back end. Front end is the code, how you the front end is the data, how you design the automated scripts. The back end is the complicated code, scripting in whatever language, using whatever tool. All right, so that's a simple definition. What about a goal? Why would a company look at developing an automation framework? So the goal would be certainly to decrease automation test creation time. We all understand automation, there's some ramp-up time to get some assets developed. If you're utilizing a strong, robust framework, creating the automated test should be a very simple, very quick process. All right. Also, as you put the pieces together, if you understand what the front end and the back end look like, you can have a team developing the automated test using the front end structure, and then a team automating or creating the framework itself, the code itself, the back end. So as scripts are being developed in the front end using Excel or a database, whatever, they can be ready to run once the framework is done. They should be able to run through the framework process and execute against an application. Okay. Decreased maintenance, of course, that seems to be the downfall of many automation projects, and software becomes shelfware, unfortunately, because of maintenance tends to eat the life out of an automation project after a few iterations. So you want to decrease the maintenance, and one way to do that, again, is to separate the data from the code. All right. Automation coverage is also key that a well-designed framework will give you. So you want automation to make a nice impact on the manual testing. That's why organizations invest money in tools, money in resources, and time to create automation to get an ROI eventually. All right, so we want to bring that ROI up as quickly as possible, and increasing the coverage is one way to do that. And ultimately, a well-designed framework can actually put the power of automation into the hands of manual testers. If that front end is simple enough, you can easily train a non-technical person how to create automated tests. And we'll take a look at a couple examples of those. All right. So what are the characteristics? Certainly you need some modular code. You can't be, okay, so record playback, let's throw that out the window right now. There is no record playback, all right? The tool you're using may support that. You may want to do that to start with, but you can't rely on that for execution and to bring you the ROI you want. So you have to modularize your code. You actually want to develop your framework solution based not around test scenarios, but around your automation processes, okay? Another characteristic, it should certainly be scalable. So there should be little effort required to add another business process to the framework or even another application to the framework. So you may have 3 or 4 applications in your organization that require automation. You could develop a framework around one of those applications, keeping in mind there are other applications that are going to require the use of this framework. So you got to take into account the technology, the processes, things like that. Error handling is important. You want to be able to, these scripts should be able to run unattended. And to do that, we need to be able to handle unexpected pop-ups, unexpected messages, unexpected behavior. Some tools have an error handling mechanism built in. Some do not. Certainly use those if you have them. If not, you need to create some functions or a process to handle various pop-ups and unexpected events during runtime. And all this has to do with robustness. So the more robust and reliable your scripts are and your framework is, the better you can run unattended. It's, you know, I hate seeing an organization put a lot of time and effort into automation, and then when it has to run, someone has to sit there and babysit it. It kind of defeats the purpose of automation. All right. During runtime, you should be able to run these things overnight, and whatever you have to do, and come in the morning and have a set of results. That's the goal. That's the plan. And then data management. Another characteristic, again, is Data should not be associated with the framework. It should be outside the framework. The framework reads the data and makes decisions based on that data. All right, so those are some of the characteristics of a framework. So let's look at some of the elements. So a simple front end. So you have to understand who your customer is. So by customer, I mean who's going to be creating the test scripts. And again, I'm coming from the point of view of a consultant who comes in and creates frameworks or implements frameworks. So I'm thinking all the time, who's going to use this framework to create the automated test? Every organization is different, all right? I think a lot of organizations would love to see a situation where their manual testers or BAs can use the framework for their typical everyday work, for the manual testing. They know the application. They know their test. Give me a mechanism that they can use to create these manual tests in such a way that it can run through a framework. That's ideal, okay? So you have to understand their level of expertise and technical knowledge. So do they understand objects, classes, methods, functions, et cetera, et cetera? All those pieces that make up a framework. Do they understand that, or does it have to be at a simpler level? Again, the front end, okay? Do they understand test automation methodology? So to create these tests, do they have to understand principles of automation? Certainly QA principles are very important, but as far as test automation, do they have to understand logic? Do they have to understand how to put things together or whatever it happens to be? So simpler the better. And one of the keys is, can anybody be trained within 8 hours or less on how to utilize the framework to create automation tests? All right, that's the kind of the benchmark that you want to consider when designing and creating a framework. All right. The data input. So the data input should come from, again, an external source, commonly Excel. It could be a simple database or XML files, things like that, whatever your organization is comfortable using. All right. I've seen frameworks where it's been required to create another application to select all kinds of options and data and things like that to actually run through the framework. For me, that's too much effort. All right, it should be simpler than that. You're creating another development project. All right. All the rules or syntax required to create the automated test, they need to be easily understood and conveyed. So during the training, it shouldn't be a lot of confusion. It'd be very, very simple as far as how to employ the automation framework to create the automated test, again, either by manual testers or BAs or whoever. You can incorporate some keywords like clear. These are just some examples. There's a whole bunch of examples. It's just something simple. So say you have a field where you want to delete the data in there. Clear and carrots would do that for you. There may be some date-sensitive fields. You can put in something like today, and the carrots plus 30 is 30 days in the future, minus 30 is 30 days in the past. Okay, so you can have some of those triggers in there built into the front end that simply says, if you put these in here, here's what they will do on the back end. But they don't know how, people who create the scripts don't have to understand how it does it. They just have to understand that's what it will do if you put this in there. All right, so those are just some of the syntax rules that you can build in to a framework. So the back end. The back end is the most difficult part, of course, to put together. So the back end, as far as definition goes, it consists of the code in the form of drivers, process routines, functions, recovery routines, data handling routines, things like that, whatever you need to do to technically make that automation work. All right. So the technical side, of course, is the script in whatever tool, whatever language you're utilizing for your scripting builds all this in. But the key, though, is to be sure that the framework is scalable and maintainable. So what I like to do, I always like to think of who's going to be following the team who's creating this framework, who's going to be following to maintain it. You know, the same employees may not always be there. Contractors certainly won't always be there. You want to consider maintainability. How complicated is it to understand the framework so that somebody can go in and maintain it? Or somebody can go in and extend the framework to include another application. okay, another project in the framework, okay. So again, the code must be modular in design, well documented without a doubt. So I'm not talking about a separate document, although that's important as well, but also every piece of it should be documented as far as what this does, why it's doing this, things like that within the back-end code itself, all right? Reporting is very important. It needs to be detailed, clear, and concise. And I'll give you an example. Lots of times you'll see organizations will throw a fail condition, but they don't state what the actual value was. So for instance, I'm expecting this value to be in this field, so it's not there. Okay, well, what was there? Report that back to the test results. Take screenshots are very important for objective evidence when it comes to either even pass and fail conditions. They're important to do, all right? So kind of to wrap it up, you don't want to have someone have a master's degree in software development to go in and maintain and support a framework. It's too complicated. And you know, I love developers. They're great and wonderful, but one thing developers can do to an automation tool is make it way too complicated, or automation solutions make it way too complicated. Nothing against developers. I'm sure there's some on the line. So love you guys. You're our job security. So that's great. But my point is just keep it as simple as possible, as maintainable as possible, okay? All right. So when you're designing multiple applications and multiple platforms need to be taken into consideration. So where is this framework going to execute? What browsers need to be supported? What operating systems need to be supported, whatever that happens to be, all right? Know the scope and expectations of automation in your organization. So one of the keys for when you're developing a framework is reporting the status of the framework. There's not a lot of assets to report on when you're really developing the framework itself, designing and developing. You can't say, oh, we developed these many tests, ran, whatever it happens to be. It's kind of hard to do early on in the project. So you have to have a way to communicate and manage expectations, okay? But overall, data is the key. So what drives the framework? Data has to drive the framework in some form, okay? So data can be input data, could be expected data, okay? It can be keywords. So there are a number of types of frameworks. They basically come down to data-driven or keyword-driven or a hybrid of the two. There are individuals who you can really kind of, you know, put some really cool words on different types of frameworks, but when it comes down to it, everything is driven by data. Name it what you want. It's some form of data, whether it's a keyword, data input, or whatever it happens to be, a process name, things like that, okay? So also the framework should allow for running multiple sets of data, and it's called data drive. It's iterations, right? So you have a process and you want to run multiple sets of data, and there's some negative scenarios, positive scenarios. The framework should account for all those variations, all right? So let's look at some examples or some ideas of a simple design versus a complex design. And a lot of that is dictated by what needs to be automated. What are the projects in scope? What's the structure of the organization? Things like that. And we'll look at some examples as well. So let's look at the kind of a comparison between simple and complex design, pros and cons of the two. All right. So as far as complex, and these are generalities. These are what I've seen over the past 10, 15 years. So the generalities, if there are some here who have experience with automation, you may see something else, but typically here's what I've seen. All right. A complex framework pro is typically their better scalability. Okay. So typically it would be easier to bring in another automation project, another application to test into a framework that has a complex back end, because complexity typically means that more variables are handled in the back end. More environments are handled, things like that. All right. Typically less maintenance is required. Everything's tends to be extrapolated out at a higher level. So it kind of, and that's kind of a hard phrase to say without explaining it, but there's less maintenance, there's less code, less script per application. Okay, it's more at a higher level. All right. Complex frameworks typically take more time to develop, and they also require more resources, more senior resources to develop complex framework design. All right, and those 2 points there kind of add up to, they're typically more expensive in the front end before you actually have something you can run. More technical skills, more technical knowledge is required to use the front end typically as well. And again, it depends on the on the framework design, but a complex framework may require more technical knowledge of the person who's developing the scripts themselves, whether using Excel or a database for the data, whatever it happens to be. Because the complex framework is probably relying more on that technical information at a higher level than it is just looking at certain objects on the screen, things like that. So those need to be defined more clearly at the technical level in the front end. Okay, it's typically, again, what I've seen. All right. So simple framework, they do take much less time to develop. All right, they're easier to troubleshoot and maintain. It doesn't take a lot of skill to go in and maintain a kind of a simple framework design. And by definition, it's simple. It's easy to understand the flow of data. It's easy to understand what process does what this library is for, things like that. Okay, it's just easier to grasp by somebody just looking at it. But again, there's more maintenance is possibly required in that regard, because a simple framework design is probably relying on more specific information, application by application. So when something changes, there's going to be a little more maintenance possibly for a simple framework design. And again, typically they're less scalable. It takes a little more effort to onboard another application in your organization or another business process for an existing application or application in your organization. So it typically tend to be a little more difficult to onboard something else. Okay, so less scalable. All right. So let's look at a couple of case studies. And again, in our class, we'll get into this a little more detail, but we have a limited time here. So a case study will kind of bring this to light a little better, what we just talked about. So some real world examples. All right. So here's a case study. So here's the diversified holding company providing financial services, a financial company. They have over 6,000 advisors serving 2.5 million clients. All right. They bought another wealth management company, and so this is a data integration project is what we're going to be looking at here. One financial firm to another. All right. Very complex environment to work in. So some of the requirements, there actually were over 100 applications initially in scope, and that was greatly scaled down to about 5. But overall, the framework had to work seamlessly with multiple technologies, so different web environments. They still had some old VB ActiveX applications as well, a lot of tabs, a lot going on, kind of the old messy versions of stuff. And there was some custom infragistics controls as well, and that was a critical application. So there are 5 unique critical applications employing various those technologies above. We had a tight time frame, so when we executed these tests, they had to run on multiple machines simultaneously in a virtual environment. And at the time, we didn't have a test management tool to manage the test execution. All right, so we had to manage the execution on those virtual machines in an automated fashion. But in the end, we then had to report those test results to Quality Center. And they had to be traced to those manual tests that the automated script was replacing. All right, so those are kind of the requirements for this particular complex framework. All right. Oh, a couple more things. The front end had to be simple enough for non-technical people to create the automated tests. All right, so non-technical. So these are individuals with no automation experience. And the other caveat was that at the time we had no access to the applications. AUT is the applications, okay? Application under test. We had no access to the applications. And onboarding or getting access to applications took very, very long, very complicated processes. As you can imagine, in a financial institution, it's not, you know, email somebody and you get access. It's quite a process to do. So we had to rely on manual tests. So the automated tests and the framework were being designed without touching any application. We needed to capture screenshots for every step that was executed, not just pass and fail conditions, but every interaction with the application. We needed a screenshot for objective evidence, okay? So those are the requirements. So as far as designing a team for this, we had an automation lead, 4 very senior engineers to develop the framework, then 4 junior to mid-level automation engineers to design shared repositories, and then also develop the script. So as you go through here, think about the applications in your organization, all right, that would be in scope for automation. And think about, would it require a complex framework, do we think? You know, what's the complexity of the application? How many do we need the framework to interact with? You know, things like that. So think about, do I need a simple framework design or do we need a complex framework design? Here's an example of a complex framework design. You see, our hands are tied in a number of areas, especially having access to the applications. Just wasn't an option at the time. Eventually, of course, we got it, but early on, and for months, we had no access. All right. So this particular framework was developed using VB Script in QuickTest Pro 11. It was kind of a keyword and data-driven framework, and you know, kind of with some technical notes. We're using scripting dictionaries to map object classes and actives in a function. We had to develop custom object classes. So as far as, let me explain what an object class is. An object class is a web edit field, a link, a web table, things like that, are classes of objects. Okay, we had to define custom ones because of some of the custom objects we were having to deal with as far as the infragistics controls, which is the next bullet down there. All right. So they had the one framework and one set of code had to perform across applications developed in, like I mentioned, web.NET VB and the infragistics controls. And then the test results had to be updated, had to connect with Quality Center, find the manual test in the test lab, if you're familiar with Quality Center, and update a pass or fail condition for that manual test. So as you can see, there was a lot of requirements, a lot of features that had to be built in. In the end, it was very, very complex, function-driven, you know, technical kind of stuff we had to put together and design. All right. So we also had to support multiple executions for multiple machines. We ended up developing a load balancing feature using Excel. And a test would start, we can run tests from multiple machines and run them against multiple machines, and the file would keep track of what machine was currently running a test. And the code, the solution would go out, look at that file, and select the machine that wasn't being used, run the script on there, and then release that machine. The next script would look at that file, find the next machine that was available, select it, assign itself to it, and run on that machine. So it's one of those fun things to put together. Every automation engineer wants those fun technical things to do, and that was a blast to do. We had a good time working around that challenge, I guess. All right. Again, required no technical skills to create and maintain the automated scripts. There was had to be some understanding of, we'll see in a minute, some understanding of object classes and operations against those objects, but those were simple to train on. Data driving was built into the solution as well, so every test scenario can run multiple sets of data, and also on both positive and negative as well. Okay. So we built the framework based on these requirements, but we also took into account the likelihood that the organization would continue with this framework and build out their more automation in the future, including and bringing on other applications. Okay, so we looked beyond this initial effort, and we kept in mind, before when we're gone, when this team is gone, the organization can pick this up and use it elsewhere. So that was our focus as well. All right. The front end simply used Excel. Everyone understands Excel. Very, very powerful tool. Very simple to understand. Everyone's worked with Excel who's been working in an office for any length of time. So no training on the front end tool to use. All right. And for those of you who understand automation, there's something called an object repository possibly, and that simply maps those objects in the application you're working with, so the tool can recognize the objects. For web applications, and again, this was required because of lack of access to the applications. We didn't need any object mapping in there. The solution would actually find the object based on the name we gave the object. It worked incredibly well. So everything was built on the fly and found everything it needed to find. So also, and we'll look at some examples, but the data was varied in such a way, or the design was varied, so the data could ignore steps that weren't relevant to that current iteration of data. So you have a scenario that goes step by step by step by step. Iteration 1 may require all those steps, all those objects to interact with. Iteration 2 may only require half of them. So if there was no data in that field, that object was not even considered, wasn't even looked at. So again, it was data-driven. The data just made or drove the automation in the way it wanted it to. Okay. So if there was no data for a user or customer ID, we didn't bother with the customer ID, just ignored it. All right. So here's an example. Here's what the front end looked like in this complex framework example. So again, there needed to be some understanding of object classes, actions against an object, and values. Okay. So the object classes, we had to create some custom ones possibly. The name referenced the object itself. And we had custom actions as well. Invoke would actually open up the application that was mentioned. Then we click and select, and we could do verify or get. An action get would actually get that information from the object during runtime and write it out to the output column. And the result was pass or fail for each of those steps, a screenshot file, and if there was any other comments generated by the tool we were using, they would be written out to the execution comments. Okay. So this is a test. This is the script. No code, no looping structures, no conditional statements. All that is handled in the back end. Again, a very complex back end. So there are two sheets. I don't show them here, but there was a test steps. This is the test step sheet. And then there was a data sheet. So the data sheet simply contained the parameters and the values under there. So if you look at column D, the carets around the FA and type and model and product type told the framework that that's not the value to enter in there. That's a reference to the parameter on the data tab. So the script or the framework would go to the data tab, look for the FA column, and pull the value for that iteration onto there. So very nicely data driven. You can have, we had up to, I think the maximum was 53 rows of data in the data tab. And for every row of data, a new sheet was created in the execution file, which was Excel. This was copied to an execution file. And every iteration of data had its own sheet. And the other cool thing we did, someone figured out, was if that iteration failed, just make the sheet red. So we could see the failed iterations of data. So that worked out really well. Okay. So that's a complex framework design. And you can understand the requirements, the environment that we were working in. It required something that was very highly extrapolated. There was no, for all the applications we ran against, there was not one step that referenced the application or the object in an application. Everything was in function libraries. That's how we had to build it because we did not have access to the applications, unfortunately. Would have been nice, but that kind of helps when you're automating something to know what you're automating. But in this case, we didn't have that. So everything was at a very, very high level, very technical. So let's take a look at a more reasonable example of a framework design, all right? And you'll see in this example there was much more limited scope, access, readily accessible to all the applications. So it required a different framework. Okay. So there are only 3 web-based applications. Okay, so first of all, one technology to automate against web apps. All right, and not complicated. It wasn't HTML5 or Java, things like that some tools have issues with. These are pretty simple. So we had access to very limited resources. There wasn't a big budget on this project like it was on the other one, and that's another thing that kind of dictates, the framework design is the budget to do this, right? So in this case, we had one senior engineer on the project. And then also, the company also had a junior resource that needed to be mentored through the project. They had to understand the framework, and so that when this engineer was gone, the senior engineer, this person could actually pick it up, maintain it, and build other projects on it. The other thing that ended up happening kind of midway through is the onboarding of some offshore resources to be engaged on the project as well. So they learned the framework design very, very quickly, and then incorporated another application in that framework design. The front end had to be very, very simple, even simpler than the other one, and so that even the manual testers could just pick it up and start developing the automated scripts. So those are the requirements. So again, some of the design features, this again was in Quick Test Pro, or Unified Functional Test, which is what it's called now. It was keyword and data driven based on the application business processes. And those processes, I guess, were considered, you consider those keywords, all right? And the parameters, which is the data. So we had different data types to manage the data. Of course, you need input data. This is the information that goes in the edit fields, selects from drop-down lists, things like that. Verification parameters, these are actually expected values. So if a parameter name began with EXP, then that was an expected value. It wasn't an input. And at runtime, the framework takes that expected value, compares it to what's actually there, and reports a fail or pass condition. Okay. There are also decision or action parameters. So a decision parameter simply creates an action against an object. So click save button, click cancel button, yes or no kind of thing, all right? So those are built in as well. And then also output parameters. So any parameter with underscore out, it was a placeholder, essentially a cell, that allowed the framework to capture data and write it out to the data table, to the runtime data table that we were executing from. So what could happen then is, say a customer ID is generated by the application, it can be written out to that cell, and for any processes running subsequent to that, later down the road, it could share that customer ID with another process as input. All right, so when it comes to data, it's important to be able to share data among different steps within a test for sure, but even from one test to another possibly, if that's required, all right? So consider that as well. So the data that your application generates, be sure you capture it, even if it's just for documentation purposes, just for posterity. We need to know that this test generated this asset, this application asset, this customer, this order, whatever it happens to be. And then also, not just for documentation, but also for later use into another process in that test, okay? All right. So some of the design features, there are some low-level common functions to handle complexities of the detailed data management, object identification, and manipulation. So it's one thing to identify an object. It's another thing to get the tool to work with the object as well. So those are all dealt with in the background. Reporting is filtered through one function, okay? So a lot of tools, including Quick Test Pro and most of the other tools, have a reporting feature, some way to actually report to their standard reporting layout, reporting tool. But there's it's limiting. There are limiting factors in that. So if you route all the reporting through one function, you can then dictate when to capture screenshots, how to structure the detailed messages. What if there's a critical failure? So another thing to really design into your automation framework is what is a critical failure and what is not a critical failure. What if a page does not load in the application? I would consider that a critical failure. You can't really continue the test if a page doesn't load. So you need to understand those critical failures and put triggers in your solution to stop the test from running. Machines, those resources, the virtual machines, are tools that we can use to run the test. But if it's sitting there waiting to run something, waiting for hours because it's stuck on something and the application broke basically, but the tool keeps trying to run this test, you're just wasting a lot of hours on the resources, on your machines. So know when to break out of that test and stop that test from executing. Okay, so that's a kind of a critical failure there. All right. So the front end design, again, it used Excel, but it was simpler in its structure. All right. So the front end Excel, the scripts themselves had multiple tabs. Each tab represents the name of a business process. So there's a login, there's create customer, modify customer, whatever it happens to be. All right. So each tab represented a process. And at the top, the first row of each tab contained all the necessary parameters to handle both positive and negative scenarios in those tests. So however that process could be used, every field in the object was represented by parameters in the sheet. Okay, and we'll look at an example in just a minute. Outputs captured by output parameters, and those are written, like I mentioned before, written out to the sheet. And they can be shared in just by using a simple Excel formula. Okay, this input from the customer ID equals the output from the previous process, so now it can be shared to a subsequent process. The sheets were structured in such a way that there was no technical skill at all was required to create the automated script. Just simply understanding the structure, how the data flowed, how the data was read, and how to input the data. That's really all was needed. Multiple applications were easily incorporated and integrated by using tabs. So one test can execute against multiple applications. So you can have a login application 1 sheet. It does all it needs to do with multiple sheets related to that application. Then you can have a login application 2 sheet in the same test. And it can open up that application and share data that was created by the previous application sheets. So it's very, very easy to develop integrated tests using this framework. All right. Here's an example. Okay. So there's a test summary, but we won't get into all the details. But an example here of a registration. All right. So at the top there, you see a number of input parameters. There's some decision parameters. Click registration button. Click change link. Those are yes or no entries. Okay. Another number of clicks. So there's an expected change location. So anything that entered in here, it verified that's the expected value. It verified that that was correct in the application during runtime when that step hit. All right. And there's expected messages as well. So the image down the bottom, an example of actual input into one of the tests. And this was a routine. Oh, the other thing is just briefly, not all these tabs are required for every step, for every test. So you don't always have to manage equipment or call forwarding or things like that. So any test that didn't need those sheets could just be deleted, and the sheets could be moved around in the order that they execute. Okay, so it's kind of simple to control the order of execution just by moving those sheets in the right order from left to right, of course. So the bottom example here is actually beating up on the login page. So throwing in wrong passwords, missing usernames, things like that, and expecting the page to handle those false entries. So we had so there's username, password, also environment, things like that. But then we had to click sign in yes or no. And there was an expected error message So this is just text sitting on the screen. We can verify whatever text we needed to, we expect it to be there by entering something in that field. All right. If you look at the expected links, so once we had a successful login, we can verify all those links existed. All right. Pay my bills, view statement, view appointments. The tilde simply represents each of those strings in between is a separate and unique verification. All right. So the script part, the function that ran this simply said, split that out. Each one is handled differently. Pay my bills, does it exist? Yes or no, pass or fail. View my statements, does it exist? Yes or no, pass and fail. Okay. It was very easy to put in multiple verification points in one cell. So we did a lot of verification very simply in that one cell. All right. The back end, again, was much simpler to design. There's a master driver. Every framework has some kind of driver script that kicks it off and reads data and branches out, calls different things, stuff like that. This is a much easier and understandable method of developing a driver script. So we had sub-drivers that every process for the MS application was in this driver. Every process for the ATIM application was in this driver, CRM was in this driver. So again, all the applications that were in scope for automation was handled by the framework at one point of reference. So you can create tests that tested just one of these applications, all right? So if there wasn't a sheet referencing MS application, then that wasn't called. So you can incorporate just one application at a time or incorporate integration of these applications by a test, all run from the same driver script. Very, very simple to design. All right. I guess that's relative, isn't it? But simple and related to the other one, we'll put it that way. All right. So the script itself, there were processes, or in UFT they're called actions, but there are groups of code, however they're defined in the tool that you're using, that reference the objects. All right. So unlike that complex framework, this has to reference the specific object in the application to interact with. And it's simply sending in the parameter. If the email address has a value being sent in, then it sets the value. If there's no value in there, it ignores it. Okay? Things like that we built in. So very simple. Again, if you notice here, there's no logic. There's no conditional statements. There's no for loops. There's no do whiles, no structures, things like that. Very simple. Here's the object. Here's the action, set, select, things like that, or click, and here's the value. All right. Very simple structure, very easy to automate, very easy to create processes that handle everything imaginable for that process right from here. Okay. So what about planning? The order in which you really want to develop a framework is you want to start with the front end. All right. Once you understand the applications and things like that, you need to think about who's going to be automating this, who's going to be developing the tests. So what's the front-end design going to look like? How technical is the front-end design going to be? What tool is it going to use? Who's going to use it? How technical are they? How much training is it going to be required to work with this front-end design? All right. You certainly want to utilize input, output, decision, and verification parameters, so you need to build that flexibility into the front end. All right. And like I mentioned before, you can use some of those key terms, clear, and today plus 30, things like that can clear field down and so on and so forth. All right. So that's kind of how you want to start. Start from the front end, understand what the input's going to be, then you design your back end around that. All right, so once you define the front end, those tests can begin to be developed. Those scripts can be developed, and then they'll be able to run once the back end is finished or just about done being designed. Okay. I usually, if I'm in front of people, I say, does that make sense? I see people nod or shake their heads, or I can't see or hear anybody, but I hope that makes sense. And that's why we'll look at questions in just a minute, okay? All right. So how are you going to feed that data? So you have your front-end design, which incorporates the data. How does that data get fed into the framework? All right. How does the runtime data, those customers, order numbers, things like that, get captured and reused in your framework? How are multiple iterations handled? Okay, because you want to leverage your test. You don't want to have a scenario for every iteration, every different set of data you want to run through the same scenario. Create the scenario once, put the multiple iterations of data through there. So how are you going to handle that in the framework? What type of reporting is required and what level of reporting is required? You might want to create a high-level report, kind of a management level report, but you certainly want a detailed report as well to show every step that occurred, screenshots possible, things like that. All right, pass and fail conditions. And then unexpected events. Very, very key to any successful automation project is how do you handle unexpected events. Okay, again, the tool, some tools can handle those with built-in sections or wizards that will help you do that. Others, you have to build that in. Okay, I personally, even though the tool has a built-in, I typically like to handle that programmatically. Just gives you a little more flexibility in that regard. All right. And that's it, really. As far as the slides and today's presentation, again, this is just a subset of what we'll cover in the class on that Tuesday. Oops, wrong mouse. During the convention. All right, so let me look at some questions here. If I can expand this out. 1 second. Trying to see this a little better. Oh, will the presentation be made available after the webinar? I believe it can be. I believe it can be. Okay. All right. Any other questions? I can't imagine that's the only question. Last time I presented this, there was a ton of questions. So if you have questions, now's the time to ask, or as they say, forever hold your peace. The class will incorporate more than just automation. It'll also incorporate the some basic QA terminology, techniques, methodology, principles. Okay, because behind every good automation design, framework design, is good QA practice. So one of the things we'll actually talk about is how to structure manual tests to be suitable for automation, how to manage requirements, things like that, and go through a number of examples. Then, of course, there's going to be at the end a test that covers the course material. So if there's no more questions, let me just scroll through again just to make sure. Okay, if there's no more questions, I hope you guys, you understand that at the end of the month, by the end of the month, you can save $50 again on the price, or I'm sorry, $500 up to $500 on the price of the conference itself. I certainly hope to see you there in the class. We do have a great time. It's a very interactive class. I hate hearing myself talk. This is kind of painful to me. I'm just hearing myself talk, but I love having interaction. So we'll have all levels of experience in the class. Those who have very senior automation people. And some who may be brand new to automation. So you may be sent to this class by your organization to learn about automation. How do we implement automation into our organization? This class will suit you as well, okay? We don't get into a lot of technical stuff. It's just not necessary. We get into broad concepts, some of the things we covered today. But it's really, you don't have to have any kind of background in automation to get a lot out of this class. It should be very valuable for you. So that being said, I think, okay, that being said, there's no more questions. We will end the webinar. Thank you so much again for attending. Greatly appreciate it and hope to see you all at the conference coming up in the summer. Take care.